All right, so today we're going to continue talking about solving inequalities. All right, so looking at this inequality I have here, is 1 less than 4? Yes, that is true. So if I add 3 to both sides, is it still true? So if I take 3 plus 1, is that still going to be less than 4 plus 3? Well, we get 3 plus 1 is 4, less than 4 plus 3 is 7, and that is still true. What if I subtract 3 from both sides? So I say 1 minus 3 is less than 4 minus 3. 1 minus 3 is a negative 2. Less than 4 minus 3 is 1. And negative 2 is still less than 1. Okay, if I multiply both sides by 2, so 1 times 2, is that less than 4 times 2? 1 times 2 is 2. 4 times 2 is 8. And 2 is less than 8. So that is true. Both of those are true. All right, dividing both sides by 2. So 1 divided by 2, is that less than 4 divided by 2? All right, so that's 1/2 is less than 2, and that is true as well. Okay, this time I'm going to multiply by a negative. So if I take 1 times a negative 2, is that going to be less than 4 times a negative 2? 1 times negative 2 is negative 2, less than 4 times negative 2, which is negative 8. Which is false. And I'm going to do the same thing with dividing by a negative 2. Let's look at that. So 1 divided by a negative 2, is that the same thing, or is that still less than 4 divided by a negative 2? Well, we get a negative 1/2 here, less than a negative 2, which is false. All right, so why did these last two become false, but none of the others? What was the commonality? Okay, we divided or multiplied by a negative. So the specific action that for the inequality to become false was we multiplied or divided by a negative number. So really quick, looking back there, what could I do to change these? So looking at the negative 2 less than a negative 8, how could I change that so that it would be a true inequality? Well, we know 2 is not less than negative 8, but negative 2 is greater than negative 8. And negative 1/2 is not less than negative 2, but negative 1/2 is greater than a negative 2. So what did I do there on both of those? I flipped the inequality sign. So the action we can take without undoing or changing the action we do, because we have to do those, would be to flip the inequality sign. So whenever you multiply or divide by a negative number, you must flip the inequality sign. All right, so let's look at a few examples. First thing I would do to solve this is minus 1 on both sides. And I get a negative x is greater than or equal to 2. Now remember, I have this negative 1 here. Oops, apologize guys, I was trying to click with my pen color. So remember, there's that invisible 1. Okay, so simplify this. I'm going to divide by a -1. And I get x. Because I divided by a negative number here, I have to flip my inequality sign. All right, so if I were to graph this on my number line, I would put a closed circle, and I would shade to the left. All right, let's look at this one. I'm going to add 2 to both sides. So I get a -x divided by 5 is greater than 4 plus 2 is 6. So now I'm going to multiply both sides by a -5 because I want to get rid of the negative and the 5. I want to cancel them out. And I get x. I multiplied by a negative, so I have to flip. It's a -30. So x is less than a -30. So put -30 on my number line. This time it's going to be an open circle because it's less than. And I'm shading to the left because it's less than. All right, so what am I going to do on this one? So because the -3 is multiplying, we have to divide to undo. So we get x is less than or equal to 27 divided by a -3 is a -9. Remember, I flipped the sign because I divided by a negative. All right. So closed circle because it's equal to. And I'm shading to the left because it's less than. All right, let's look at this one. So on this one, 4 times x is greater than or equal to a -16. So I'm going to divide by 4. And I get x is greater than -4. Why didn't I flip the sign on this one? Okay, the number I divided by, this number right here, is not negative. So therefore, I do not need to flip my inequality sign. I should not flip my inequality sign. So, open dot at -4 because it's not equal to, and I'm shading to the right because it's greater than. All right, we will look at one last one here. So what am I going to do first? Minus the 5. 9 minus 5 is 4. Which is less than or equal to 4x. Now I'm going to divide by 4. Okay, 4 divided by 4 is 1. Less than or equal to x. So my dot is going to be a closed dot at 1. So I know that 1 is less than or equal to x. Okay, typically when we have less than, I want to shade to the left. However, in this case, I do not because my x is on the right. So whenever you see your x on the right, we have to do the opposite or you have to rewrite your inequality. So I'm going to rewrite my inequality with my x on the left side. So I'm going to get x is greater than or equal to 1. Okay, notice the open side is still facing towards the x, and the small side is still facing towards the 1. Okay. Make sure if you rewrite this with the variable on the left side that you keep your inequality facing the things it's supposed to face. So small side should still face the 1 in this one, and the large side is still going to face the variable. All right, so this time we are shading to the right because it's greater than. All right, that is it for this. And we'll start talking about multi-step in the next.